All right, good afternoon, folks. It's about 1 after, so I'm going to go ahead and get started with our webinar. We're really excited to be able to share with you guys new development in IFTDSS, the quantitative wildfire risk assessment that we just released last week. So we're really excited. We've been working on this for a while. I'm Nicole Viant, so I am here to introduce Caroline Noble, who will be giving the webinar, along with Josh Hyde, who will also be helping out today with the webinar. I wanted to acknowledge the other two key people on our development team, being Ken Ernstrom and Bree Schuler, who are not present today, but they definitely helped us get risk assessment work done and available to you guys. The goal today is to really just show you how to do a risk assessment in IFTDSS, what the steps are, how to get it done and get a product out. So we'll do a little bit of highlighting of the products that we have right now. Unlike most releases, we actually haven't finished developing the reporting aspect for risk, so we're still working on that. And that'll come probably this fall. So we're looking forward to getting that out and available for you guys. And when that is available, we'll do some more follow-up webinars on really how to highlight the application of risk, how you're going to use the reports and whatnot from IFTDSS to kind of do your job for fuels management needs. A little bit of housekeeping before we get started. The first is, on entry, we muted all of you guys. So please use the question box if you have questions that pop up along the way, or raise your hand if you're having any technical difficulties, and we will help you. I will be monitoring the questions and I'll answer them as fast as I can as they come in, and we'll also be taking pauses here and there to see if there's any that are value added for us to read out loud and answer live on the webinar. We're also going to be recording this, and we'll post it on the IFTDSS page, which is what you can see on the screen right now under the user support, the webinars and training. So this will be up and available if you wanted to revisit the webinar or share it with others who couldn't make it today. And the last thing, as far as housekeeping, that I wanted to point out is we have posted in the handout section 4 of the handouts that kind of correlate to all 4 phases of the risk assessment work we've done. So this is kind of the 4th and final phase for risk. So we're really excited to be able to share what we have today. And with that, Caroline, I'm going to turn it over to you.
All right, great. Thanks, Nicole. Hey, everybody. Caroline Noble with the Wildland Fire Management RDNA, based in Tallahassee, Florida, and bringing you what has been long-awaited risk assessment in IFTDSS for us. We've been working on this for quite some time. For today's outline, I just sort of want to go over what I'm going to talk to you about. I'll give a short IFTDSS introduction and background, and then I'm going to use PowerPoint to sort of walk through the risk assessment process. There's a number of steps and some dependencies along the way, and I thought I would do it through a PowerPoint forum first, and then we'll walk through it in the actual user interface of the application. Finishing up with showing you some examples of outputs, what we'll be developing next, and a little bit more on where to find more information and or find help. As Nicole said, we have done webinars in the past. We have a YouTube channel. This one will be recorded, and some of the things that I go over rather quickly, you may want to reference previous webinars to fully understand some of the building blocks that are associated with doing a full risk assessment. So just a quick background for those of you that are not necessarily familiar with IFTDSS and are coming because you're curious about risk assessment. This version of IFTDSS launched in the spring of 2017. We've had over 2,200 user accounts, and it's about 65% say federal, 41% Forest Service, 24% DOI, and then 25% other non-federal government like states and other, and then about 10% academic. We have a couple of universities actually doing some coursework with students that are up and coming in fuels management. And what can IFTDSS do now? It can already do a lot. We've been out for 3 years, and some of the things that make IFTDSS unique to some of the other tools out there is, one, is it does provide some consistent nationwide reference data sets for planning purposes, so that's especially useful for sharing data across boundaries with partners who may have limited data or you may not have shared data sets. We can model fire behavior across large landscapes. Large in this context is I've written up to 3.5 million acres. It's actually 5 million acres when we automatically add a buffer that's needed for some of the calculations. You can develop different fuels treatment scenarios and then compare across alternatives, looking at the different outputs for each alternative. Both the landscapes and the model outputs, you can generate and download reports summarizing either the fuel and landscape characteristics or the model outputs for either the entire landscape or for specific areas of interest. Number 5, woohoo, you can actually do a risk assessment at the unit to project scale, and I'll talk a little bit more about what that means. And also, not to forget, IFTDSS is the home of the required reporting fuels treatment effectiveness monitoring for Department of Interior and Department of Agriculture. So what is IFTDSS currently being used for? We've gotten feedback. We have a user advisory group. We have a forum, NEPA specialist reports, some prescribed fire planning, community wildfire protection plans, multi-years planning documents, treatment prioritization, and just the map alone with the data set that's in there, folks are using for just public meetings to have a easy to use map interface without needing robust GIS. And then fuels and fire behavior training and education. So, and we'd like to hear more if folks are using IFTDSS for things other than that. We're always curious and like to post on the landing page how it's being applied. So what scale does IFTDSS address? If you move from right to left, we've grayed out sort of the national and the regional, which are more, funding allocation and looking at risk at those broader scales. And IFTDSS is more applicable at what we call the unit and the project scale. So the unit, some land management agencies, that 3.5 million acres may cover their entire ownership or their ownership plus adjacent landowners, and some it may not, but it may be better suited at the project scale, depending on it. How many acres, but the idea is that it can be used for planning and prioritization within these units or projects, potentially comparing different alternatives and looking at effectiveness at those scales. So I'm going to switch gears there. That's just a quick background on IFTDSS and talk about risk assessment. And the term risk is everywhere. There's lots of products coming out or available, and it's kind of hard to sort through them all. One difference that I myself see is there's things that are more static viewers, these portals and maps that are available often at the state level, Southern Risk Assessment. And those are looking at burn probability and they're looking at intensity. Often it's, with an older land fire data set. I'm not sure the resolution, but I'm sure it's quite coarse to be able to present it at that scale, as opposed to what I've listed on the right called custom. These are more where the enterprise team or a contract is awarded to an expert to do either a regional or forest level or sub-regional analysis, doing a more quantitative risk assessment and utilizing local data. And there's plenty of those out there, and plenty more, I think, under contract right now, but they do get stale after a while. And I think part of the impetus of really getting IFTDSS going was to facilitate local units doing their own risk assessments in a more timely and a cost-effective manner at those appropriate scales of the unit or project scale. So there's a place for everybody at the table with this, but IFTDSS is serving a niche that hasn't yet been filled in terms of timeliness, comparing alternatives, etc. So just to be clear, the quantitative risk assessment that we apply in IFTDSS does follow the same process outlined in GTR 315, which is sort of the Bible for the framework for risk assessment. We do use a different landscape burn probability model than what's used in there, and I'll explain that when we get to the burn probability section. But this quantitative risk assessment is covering the 3 pillars of the triangle for risk. So the likelihood or burn probability, the intensity, so the flame length and intensity outputs, and then lastly, what makes it a risk assessment as opposed to an exposure analysis or just hazard is it's looking at the effects of the fire on the things we care about. So it's taking into account the effect of fire on that value, that resource, and those are defined by the user. It's ranking in importance defined by the user, and ultimately giving a loss or benefit associated with that fire. So same process applied in IFTDSS as in these other published risk assessments. So why would you use IFTDSS and not just take the regional or forest risk assessment? I've listed several reasons here. There may be more, you may have your own, but one is it's scaled to the analysis area. So whatever particular area you're interested in, it can be scaled to that if it's small enough to fit in with the acreage size limit. Local spatial data can be used. Users can upload their own data or take advantage of the reference data contained within the application. And more current data sets can be added since this is a relatively quick process to go through. The values and resources, or HVRAs, can be defined and ranked locally with local expertise. And then the scenarios for like the worst case percentile weather or the scenarios for different treatment alternatives can also be local, developed by the local unit when they're run separately and then compared against one another. And finally, the processing speed. The actual hitting the risk button and making it go doesn't take very long, 30 to 60 minutes to process, probably at the most. The landscape burn probability model is what takes the longest, and that's still hours. But the real time-consuming thing here is the planning on the user's part to get the inputs right to begin with, which is as it should be. So this is a relatively quick in processing time, but there's homework involved to make sure that your inputs are correct. Just to put it into context of a flow chart, we've been releasing this process for a while now in IFTDSS, and we broke it into different phases. So the ability to simulate wildfire using a landscape burn probability model has been in IFTDSS for a while. That's in there, and the next thing we released was called map values, which is where users can create their sets of highly valued resources and assets. And the idea is any one of these could be an independent product that a user can use, which is why we didn't wait until the end to release the whole thing as a single risk assessment. But there's value in creating these sets of resources and values. There's value in looking at just landscape probability. The next step was analyzing exposure. So you take a look at the combination of that burn probability and those values and see what the exposure is of those values on your landscape. And now finally, we've got it to the phase where we're taking into account the threat or benefit, which is what makes it a risk assessment. Another way of looking at that, this is in terms of what IFTDSS offers. This is color-coded to make it hopefully a little bit less painful. So we've released these things in blue, these processes. They're application cards within IFTDSS. You can run burn probability, map your values, do exposure. Now we're doing risk. The red is what the user has to put in. So landscape weather, values, resources, and assets. And then finally with risk, it'll be response function and relative importance. And with each of these different products or processes, you get products, which include maps and reports. So where does risk assessment fit in IFTDSS? In the cycle, the planning cycle that we've got, it's under strategic planning. It's down here on the right. You can see here's burn probability, here's exposure. Map values stands alone there because you can do that independent of these other things. If you just want to map your values and create a HVRA set, you can do that. It's not necessarily a completely linear process, but there are tutorials and things in the help that can walk you through and make it a linear process if that's helpful to users. So I'm going to walk you through one example case study from the Ocala National Forest by slide and then in the interface. And I did sort of put numbers on the steps and then show you where in the interface they are. So the steps, 8 steps here, and really it's 5 to run a risk assessment, and then 6, 7, and 8 are sort of what you can do once you've run the risk assessment, but you create a landscape, and that includes editing it if editing is needed. Secondly, run landscape burn probability. With the model we're using, it'll be problem fire conditions, and I can describe that. Map the values to create an HVRA set, run an exposure analysis, complete a risk assessment, and then view the outputs, download the outputs, or request a report. So most of this is in the strategic planning phase of the application. Number one, to create a landscape and edit a landscape is in the landscape evaluation portion of the application, but pretty straightforward, 2, 3, 4, 5. And then these last ones, we're utilizing the output that's from the workspace, which is like the file manager or Internet Explorer of the application. So we'll walk through each step quickly, focusing on the risk steps. But number one, user creates or edits a landscape. We have 2012, 14, and now 16 where it's available from Wildfire. You can draw a bounding box or use a shapefile of an area of interest to draw the box for you. The current extent limit is 3.5 million, and then it's automatically buffered by 5 kilometers to eliminate the edge effect when the landscape burn probability model is run. And then that landscape is also downloadable if people want to use it out of IFTDSS. If the landscape needs to be edited for any reason, whether there's been disturbances or whether the Wildfire classifications are off, there's tools within the application to either do global edits or to simulate treatments by using what we call Wildfire lookup tables, where you can choose treatment scenarios, apply them for a certain duration, apply them to a mask, and create new landscapes based on that. So an easy way to create alternatives for analysis. The next thing a user does is run the landscape burn probability model for known problem fire conditions. Like I said, this is where we're running a different model than some of those published risk assessments. Just to point out that the outputs of landscape burn probability here, these are dynamic within the landscape extent. So your maximum burn probability is listed, and that's the highest is in red, and then the others are scaled to that maximum within a landscape. So if you had a different area of interest or looked at the whole landscape, these colors would shift a little bit, taking into account this where the maximum is and updating dynamically to reflect it. How this ties to risk, probably most importantly, is when you do the identify tool and look at the pixel level, part of the outputs for landscape burn probability are the proportion of flame lengths. This is running thousands of fires on the landscape through random ignitions. And then this is telling you how many of those fires had flame lengths in each of these categories. And these are going to come into play when you get to the risk assessment process. But here you can see what the inputs were for this worst case scenario model run. An overall conditional flame length, and then this proportion of flame length, as well as burn probability for each pixel. So I mentioned that we're running a different model. FSIM is the model used in a lot of the regional and national risk assessments. And we're using a FlamMap 5 burn probability model. And the main difference is that the FSIM model takes into account all different weather scenarios through an entire fire season. So the wind speed, wind direction, fuel moisture content are all changing over time, whereas the FlamMap is a single weather scenario. It's a snapshot in time. And the intent is to use it as an extreme scenario to look at problem fires. So the duration of the run is short. You can actually specify in hours the duration of the analysis versus FSIM, which is an entire fire season. So it's a different mindset when you're thinking about what to run. And it's important that you do these extreme scenarios, because the model requires a certain proportion of the landscape to burn to really improve its accuracy and effectiveness. So make sure that you use these scenarios. And we do have, entire webinar just dedicated to burn probability. So if folks aren't familiar with that, it might be something to look back on. Since we'll probably get the question of future development may include FSIM, we don't have it right now because there's a lot of calibration and skills needed to run FSIM that would be hard for our target audience. And secondly, we just want to get the process in here and get it working through this RANDIG FlamMap 5 model. And then if and when we can incorporate FSIM, the HVRA characterization and the risk calculation processes will all be in place. So we just have to modify a few things. So the next step, we've got the landscape, we've run burn probability, is to map values or create an HVRA set. There's a card in the application to do that with. When you open up the map values functionality in the application, you immediately go into a split screen mode. And what's really cool about this is a lot of data is preloaded and available for selection. So you have to get familiar with the terminology of primary HVRA and sub-HVRA, which is used in risk assessment. So primary is really a category, and sub is really like the footprint or the spatial extent of something that falls within that category. So the first step is you choose what geographic extent you want. There's 3 choices. If you're going to run risk, you might as well just choose that you're going to use your landscape burn probability model output. In this case, I picked the national forest. And then when you come to selecting a primary category, what you have available is both the data used in the national risk assessment and some common data categories used in some of the regional risk assessments, as well as the reference data that's loaded within the IFTDSS application. They're going to be available to you, and it's automatically going to go and see where this black box falls and tell you what's available to you. So if I say pick communities as in this example, it's going to show me, oh, you can use low, moderate, or high. And if I check them, it's going to show me on the map, you know, this yellow is low density community. And I can just pick it. And I go through these categories of communities, air quality, infrastructure, and select the data that I want to apply to be contained within the HVRA set. And it'll also take uploaded local data. You can see underneath here that's got a lot of the burn blocks and other things for this national forest. So I've uploaded my own data, and I can use those for HVRA sets as well. So it's a nice, handy process. It's finding the intersection for you, picking your primary categories and subs, and saving them into a set for you to use in your exposure analysis and risk. Just to expand on that what I mentioned, the IFTDSS reference data is, you know, all the data we have listed here. When you add layers, you can use any of these to create a value or an asset to use in your HVRA set. And then we have the national data. They're symbolized a little differently, so you can tell which one's which, as well as uploaded data, or you can even hand draw shape files if you need to. The national data was, I think I get this right, it was resampled to a finer resolution, but we have all the data that was used in the national assessment. It's listed under national HVRA data. Those are available to pick as well, including Alaska and Puerto Rico and Hawaii in cases where we have that data. And lastly, as I mentioned, for other data sets that are within the IFTDSS reference data, you can create your own sort of subset of it. So in this example, this is sage grouse data. You know, user could pick and choose which aspects of the sage grouse data that's nationally available they want to use. And even though they might have it on their home unit, it's got coverage outside on adjacent lands, which could be useful if you're doing the risk assessment across boundaries. So that's a risk assessment. And again, there's entire webinars already done on those. The next step is the exposure analysis. And this is where it starts to build on things you've previously built. So within the application, you simply click on this card that says exposure analysis here. You choose your landscape burn probability model output, and you choose the HVRA set that you've already created. You're in a split screen mode. That HVRA set and the model output are going to pop up into the map so you can see them, verify that's what you still want. You can do some editing to each of these if you want to make some changes. It'll actually verify or check the intersections. A lot of these are data services. It'll make sure that they're currently available. And then you can save it and hit run. We do have a functionality that's kind of neat where, like I used it in this case, for HVRA set, there's not a 3.5 million acre limitation. So I created an HVRA set that would cover a number of units, a number of national forests, and then, you know, it'll find whether or not that HVRA or that value or asset actually intersects that particular national forest, but so you can have some consistency on what values, if that's desired, at a regional level or something, to be looking at consistent values across that management area. And what is an exposure assessment? Again, this can stand alone itself, and the outputs from an exposure analysis are the burn probability, which will include conditional flame length, and then something we're calling integrated hazard, which takes into account the conditional flame length and the burn probability, sort of uses this matrix or lookup table to categorize each pixel in terms of hazard. And this is calculated where sub-HVRAs are present. So in this example, I'm using the swipe tool to look at integrated hazard over a community's data. So the tan is the low density communities, and the pinkish is the moderate density communities. And you can swipe this and look at the calculated hazard in those community areas. So this is the building blocks to a risk assessment. We haven't, identified necessarily threats or benefits yet, but we've identified exposure. Where the sub-HVRAs are present, what's the burn probability, what's the hazard. And the reports for exposure analysis take those primary HVRA categories, whether they be communities, infrastructure, and give you some graphic representations of the mean flame length calculations, mean burn probability, et cetera, by primary HVRA category. So exposure analysis has its own uses, but the next step from an exposure analysis is then, okay, within these different values, what is the effect of fire? Is it positive, negative, neutral? Is it offsetting where it occurs? And multiple things occur in one geographic area. So as I was saying, the risk portion that we've added is going to take into account the losses and benefits. So we've looked at the likelihood and we've looked at the intensity, and now the risk assessment brings in the susceptibility and importance. Each product has a role, but this is sort of the culmination, taking into account all those factors put together. So within the application, step 5, risk assessment is with its friends right there in the strategic planning. You just click on risk assessment, and again, it follows the relatively fast path building on building blocks that you've already created. So within the application, when you open the card to complete a risk assessment, you'll be presented with this. Give me your exposure analysis output that you've already built. If you haven't, there's a friendly little button that sends you back to go to create an exposure analysis. And then there's this option to download or upload an RFRI spreadsheet. I'll describe that in a second. That's optional, but the main two things that the user puts in here are the response functions and the relative importance for the HVRA sets, so the primary and sub-HVRAs. And this bottom half here is cautionary. This is not from the interface, but traditionally the definition of response functions and relative importance is really a collaborative process, often done in workshop settings. Sometimes I think both fire effects workshops for the response functions and importance workshops for the relative importance, slightly different audiences. So it's important to take note that even though that you can move through this process pretty quickly and the UI is relatively friendly, this is where the homework is in getting the input values right. So getting those response functions and the relative importance, getting agreement from everybody involved in the assessment. That's the importance I wanted to mention here. And that's where this download response function relative importance spreadsheet can come in handy. This is just what it says. You can download a spreadsheet that will list the HVRA set inputs, the primary and sub-HVRA categories that you have already defined in your HVRA set. And then it will allow you to populate that in a spreadsheet format instead of the interface if you choose, and then upload it back into the application. So to dive into this a little bit deeper, let's talk about what these things are. So I'll show you what the interface and the application looks like in a minute, but the response functions, this ties back to where we talked about the proportion of flame length calculation in the landscape burn probability. So for response function, for each sub-HVRA, we're defining the first order fire effects in terms of positive 100 benefit to loss or negative minus 100%. So the values range from minus 100 to plus 100, and then they're applied to each sub HVRA for each flame length class or fire intensity level. So we've color coded them to help users a little bit because this can be a cumbersome process, but you know, the green being positive, the red being negative, and then shades of red and green with increasing positive or negative response functions. And this one here is from the ecosystem function from the national set, but these you can manually enter them. What we've built in the IFTDSS application is the national values, if you choose to use them, come pre-populated with the response functions that were used in the national assessment, but it's all editable. So those can be a starting point, but they can be modified to the local area. And again, like I said, they're based on consensus in group workshop settings usually. In addition to the color coding, we also have included some of these little graphs that kind of show with increasing intensity, you know, in this case, positive fire effects at low flame lengths, and then transitioning to more of a threat at the higher flame lengths. And again, just to tie it back to that landscape burn probability output to understand as best you can what you're doing when you are assigning these response functions, it's looking at the proportion of the flame lengths in each of these fire intensity level classes. You know, in this case, you know, they span from 0 to greater than 12 feet and add up to 100%. So each response function, it's multiplied times the proportion of flame length percentage that falls in that category to give you, for example, in this northern spotted owl potential home range, we've got 50% in the 8 to 12 foot with a really negative impact. So it's showing that you're going to primarily be in the strong negative in that particular pixel. But that's why it's important to think about as you're building this and make sure you've got outputs that make sense throughout the process, because you're going to be going back and dependent on these previous inputs. What it looks like in the IFTDSS interface is more like this, same concept. Here's some national ones already pre-populated with values that you can edit, color-coded and with the little bar charts through. And something that did not come from a national value just comes in blank, and you manually enter the different response functions for it. The relative importance, similar. This goes through consensus workshops. Often this is more of the line officers, and people document their justifications for the rankings, etc. And in this scenario, the top ranked values or assets on the landscape is assigned a score of 100, and then all the other HVRAs and sub-HVRAs are on a scale of 0 to 100. It's done a little bit differently in some different risk assessments, but the way IFTDSS does it is at least one primary HVRA has to have an assignment of 100, and then the other primaries are, you know, ranked or relative to that 100 rating for the primary, and then similarly each primary has to have a sub that's 100, and the subsequent subs in that category are ranked off of that 100. And luckily we have good help content and some right-hand panel help content to help users the first time they go through this. Once you get the hang of it, it's not too confusing, but it might take a good read the first time. And then what's super exciting to me, I really love this pie chart, is as you're entering these importance values, it's dynamically updating this pie chart, which is showing you overall importance of the various primaries and subs, and it's taking into account the relative extent. So the inner portion of the donut or pie is the primary, and then the outer portion is the subs. And if I were in the application, if you hover over it, like I know that this is communities in blue, but I'm not sure which one of these is the high density and which one is the moderate and low density. There's 3 in blue, but it'll show you when you hover over it. So it's a really nice way to remind users, because these can turn into just numbers on a spreadsheet, that this needs to be looked at in the context of the entire analysis, and relative extent does play a role. So this is a pretty useful tool as well. the download, upload, response function relative importance spreadsheet that I mentioned. This is as simple as it gets. When you download it, you get a spreadsheet looking like this, where you can populate the relative importance for the primaries, the subs. These national values have come pre-populated but editable. You can fill in the other values, and then you can upload it to the application. So just thought I'd show a simple graphic of how that works. And there is some error checking within the application to make sure that your values are meeting certain criterion. Yeah, the math. Yeah. So I'm going to break this into a couple of parts, and really the most important thing is to see that there is a lot of math going on. We have a veritable math sandwich on here on the right, and this is for each and every pixel. Every pixel is very important, but to show that each input does play a role in the final output. So if you break it into three parts, this risk or the conditional weighted net value change is really a sum of the relative importance per pixel. It's called times the response function times the proportion of flame length. All right, so response function we recognize. We know that we manually put that in. The proportion of flame length, we know that we got that from the landscape burn probability model output. I'm not going to tell you how to calculate relative importance per pixel because it's really complicated, but it sums all those for every sub HVRA or overlapping HVRA on any given pixel. So if in this case for this one pixel, we've got a threatened vertebrate, we've got endangered vertebrate, we've got some ecosystem function. It's looking at the relative importance, the response functions, the proportion of flame lengths for each of those sub HVRAs on that pixel just to come up with a value for that pixel. So this is how each of those inputs that you provide plays into that. So it can get lost in the translation, but I think it's kind of important at least to remember that it is taking into account overlapping HVRAs. So it can be additive, it could be offsetting. You know, you've got some things that are positive, some things that are negative. You can look at them through the reports and the downloads and tease out the different things on different sub HVRAs, but this ultimate value for the whole pixel calculation is going to be a sum of all those. I think I'm going to stop there before I get into trouble, but just type a question for Nicole if you have questions on the math. So lastly, once we've run risk assessment, you can view the outputs in what's called the Map Studio, and we chose to keep the viewing fairly simple. So we have the conditional weighted net value change or the expected weighted net value change, right? And the difference between the two is that burn probability is included in the expected weighted net value change, so it's going to be slightly lower than the conditional. There's good help content that explains that. And then these are binned and categorized based on orders of 10 magnitude. You know, we've got non-burnable in gray, burnable but not burned, black, no threat or benefit would be 0, white, and then these increasing and decreasing red and green for threat and benefit. And again, you can swipe against landscape burn probability, you can swipe against some of the values and assets you've defined and see your ultimate net value change on your landscape. The download that you do from the workspace, you just pick your risk assessment, hit the download button, much like we do in other things within the application, and you're going to get a lot of stuff. You'll get some symbology, you'll get a spreadsheet that lists all your response functions, relative importance, as well as those calculations for relative importance per pixel. You can do the math to your heart's content, and then you're going to get these raster bands for each of the sub HVRAs as well as the burn probability. So lots of good stuff in the download for external analysis. And then this is what we're still working on, but you'll request a report that'll come up HTML within the application or as a downloadable PDF that'll break out conditional expected net value change as well as showing the response functions and the relative importance inputs. And it'll be summarized at both the sub HVRA level and the entire analysis area level or the area of interest level. So with that, I'm going to pause, see if there's comments or questions, and then I'll show you the same thing I just showed you in the interface of the application.
So far, we've actually only had one question, and it was about how crown fire flame lengths are calculated. And I just wanted to point out that we do use the landscape burn probability model in IFTDSS is the same as Plan Map 6 Desktop with a few enhancements, but at its core, it is the same as that. And there's a lot of technical documentation that you can dig into if you want the specifics on that. Thanks.
All right. Thanks, Nicole. So within the application, I had that, easy steps 1 through 8 shown on that one slide, but I mentioned if you go to the planning cycle, the first 2 steps, so creating and editing a landscape, or within landscape evaluation, you've got create landscape, edit landscape. I'm not going to demonstrate those. They're pretty straightforward. And then the meat of what we talked about is here under strategic planning. So you've got map values, model burn probability, do an exposure analysis, and do a risk assessment. Again, not necessarily linear, but there are dependencies as you move through this process. The model burn probability is simply the model inputs of weather, landscape, etc. The map values I might show you quickly because it's hard to describe in a slide, but as I mentioned, it comes into a split screen format. And you select the geographic extent. I'll just pick a model output for one. So it'll automatically load that area. And then as I choose different primary categories, it's going to start listing for me what's available. It's listing the national data, which is represented by the CONUS symbol. It'll list any IFTDSS reference data that would be represented by like a Nike swoosh kind of symbol, like that. And it'll also list any local data that I have. And I can tab and say just user data to see my uploaded treatments, or I can look at just reference data, or I can look at all data. And I just start selecting them. And as I select them, they're added to my category, in this case, infrastructure. They're plotted on the map and they're added to the legend. So I just populated infrastructure. If I scroll down, here's my pending HVRA set. I've added these 2 things for infrastructure. I could go to recreation. Again, it's going to give me these available data sets. I can pick a couple. Those are added. I name my set and save it. And I can do an exposure analysis or a risk assessment using that set once I save it. And again, it can be bigger than the 3.5 million acre extent. So that's the mapping values from strategic planning. Exposure analysis, like I showed in the slideshow, is just a couple of inputs. You pick your landscape burn probability model output. It will give you a warning if I mentioned this. I did not hit the recommended 98% burnable burn target. You can still proceed, but that's kind of a heads up that maybe you want to rerun that with some hotter, drier conditions. Make sure. And then I can choose an HVRA set, and I happen to have several, and it'll tell me which ones are available, which ones intersect. I can just pick one, and it zooms way out because that HVRA set has a big area of interest associated with it. And when that happens, it'll say, hey, create and save a new one because your HVRA set is for this whole area, but you really only need it for this little area. And it'll do it for me. All I have to do is hit create and save new, and save it. And this is all calculating or looking for intersections behind the scene. As you can see, there's some things in italics, there's some things in red. So this computer is working really hard pulling from all these existing data services to see what intersects and what doesn't. So red means, I believe it's still looking, it's still calculating. If you get like a grayed out italics, that data service happens to be down, which doesn't happen very often. But you can get these messages that just sort of say, wait until the data loads. So that's the exposure analysis. And then finally, the risk assessment, like I talked about. I showed you that it has, you pretty much load your exposure analysis, and then you just have to define response functions or assign relative importance. It defaults to the full screen, but you can go into a split screen mode, so that exposure analysis will pop up on the map, and it'll show the HVRA set things that are in there, and it'll have landscape burn probability already pulled up. So that can kind of help you make sure you've got the right set. You're looking at everything you want to look at. And then the defining response functions, as I mentioned, you can just type them in manually, and it'll give you an error if you type something that's not correct. and the nationals are pre-populated. And you can see it can get kind of laborious. That's why we have the spreadsheet functionality. If you go into full screen mode instead of with the map, you get the benefit of having these little bar charts, so you can see, just validate for yourself that you're getting the right trend with increasing or decreasing flame length. And then the relative importance, as I mentioned, is going to populate this pie chart dynamically as you go. I'll have to put values in before it starts populating, but if I just make up some values, it's worth waiting for. This is so cool. It's my favorite part. One more. Then you start putting in other values. You see? Do I see that? Pie chart starts showing me, like, for communities, the low is here, the moderate is here, and the high is here. And as I populate everything else, that's going to just update and get the colors for the other ones. I don't know, it might not be as exciting to everyone else's to me, but I think it's really cool. So as you populate that, you can verify that you're getting the relative importance as you want it. Then you save it, and you hit run, and you've run your risk assessment. And once you hit run, it'll take you to the workspace, which I said is like Internet Explorer. We've implemented some sorting functionalities, so you can look in the folder where you store things, or I can just go to where are my risk assessments and find a risk assessment, and then you can say download, copy. I want to run it again. I want to do it with a different landscape and landscape burn probability to do some comparison. You can do a quick view my response functions relative importance to make sure that I know which set it is that I'm using, or you can say view on map. And when you view on the map, it'll pop open with the legend populated. And as I described in the slideshow, you've got your risk outputs of either conditional or expected net value change. You can toggle between them, see that your expected is slightly lower because it incorporates burn probability. Again, there's help to help you distinguish or understand which might be more applicable, or we'll have future webinars that dive a little bit deeper into what to think about when you're applying these. You can toggle on and off your different HVRA sets. You can swipe, over your different things. Oops, picked a bad one. Anyway, trust me, you can swipe when you do it right. And then you've also got your landscape burn probability, your proportion of flame length, so you can start to tease out what might have caused the different values in your risk assessment. And you also have a handy dandy like collapse all layers. If it gets too busy, just say, okay, here's my risk, here's my HVRA sets, and kind of toggle them on and off that way. So with that, I think I will pause. I could show you a quick teaser of what the reports are going to look like. This is from our test environment, just to prove that we're really working on it. So for a similar analysis, I've identified an area of interest of using a forest boundary. I'm getting a map of the conditional weighted net value change, the expected weighted net value change, and then a bar chart showing the distribution for both the conditional and expected. The conditional weighted across the whole analysis area. We will have it by sub. I wouldn't bank on any of these values yet, but just like other reports, we'll have the downloadable PDF or different portions of it as a spreadsheet, tabular values, etc. So a little teaser of what's to come there. Are there any more questions at this point, Nicole or Josh?
Sorry, there have been quite a few, so I was just typing answers.
Oh.
So we just had some questions just about the ability to upload a landscape file that you've created outside of the system, and unfortunately that's not something we're going to include probably anytime in the near future just because of limitations in our mapping platform. We also had a great question about how do we deal with the values that are point files or lines and polygons, and we just do a true intersection. We don't buffer them, so if it lays on that pixel within the landscape, that is what gets mapped with it. We had a question about downloads. So yes, in the download package, everything that you need to do to create a risk assessment, as well as the actual risk maps themselves, are in that download and available for you to use outside of IFTDSS. I think the last one that just came in is there going to be a ability to send a report to WFDS, and not directly, but I know you can download when they're done. You'll be able to download them and save them as a PDF, and then you could upload that into WFDS based on the WFDS protocols. And I don't know exactly what they are right now, but I know that is something that is possible. I feel like maybe it's only Word document, so I'm not strong enough on WFDS to be able to answer exactly how you can do that, but you will be able to download PDF form of the reports and get them outside of IFTDSS.
Whew, cool, good questions. We've got about 10 minutes left. I was just going to do a very quick what's coming next teaser. Obviously, the reports are coming next, and then hand it to Josh to talk quickly about user support and that sort of thing. So, whoops. I did create a couple slides. Just in the future, after we get the reports finished, we want to get into comparison functionality for the whole application. We're still in the early design phases of this, but essentially compare risk assessment, compare exposure analysis. You know, that there's caveats that need to be thought about with each one of these. In this case, I sort of pulled up what little things you can do now. In this case, I've got all 3 of the national forests in Florida, their risk assessments pulled up, which if you, you know, use a similar weather scenario, if you use the same HVRA set, which I created, in the same response functions, you know, there's some comparisons that can be done. The relative importance may or may not be consistent between the forests, but there is some ability because of the way we've been these on the orders of 10 magnitude that you can look across units if that's useful for the questions you're trying to answer. And then the other thing, we have help content on this, but if you do want to compare alternatives, you know, we have everything to run the different alternatives. It starts with editing a landscape to simulate a treatment, running a new landscape burn probability, then holding the ignitions constant, the relative importance and response functions constant, and ultimately you'll get a different risk output. And then for now, you can swipe between them, or in this case, I just did the identify tool on 1 pixel of, you know, the risk assessment straight up, and then a risk assessment post-treatment with a thinning treatment. So within the application, there's a few things you can do, and certainly with the download, there's more things you can do, but that's where we want to go next, is the ability to compare alternatives, treatments, and look at different outputs, which could include risk assessment and exposure. So with that, I think I will hand it over to Josh to talk briefly about some of our tech transfer and support stuff. Coming your way, Josh.
Caroline. As far as the webinars go and user support, if you're on the IFTDSS homepage, we have several options under user support. So this webinar, as well as past webinars, that's under the webinars and training page. So see, right now we've got this one scheduled for today, and as soon as it's uploaded into the system, it'll be listed in this recorded webinars section. There's also the past webinars on exposure analysis and burn probability that you mentioned earlier, Caroline. For more interaction with the IFTDSS user community, we have forums listed under this user support. So you can go in and choose between the questions and answers forum, which is basically that for IFTDSS users, users sharing questions about the system and answers on how they've used it. And the ideas exchange is kind of like a wish list. If there's things that you would like to see in IFTDSS, either in the near future or further out future, this is a great place to post that. It's reviewed by the development team, so they keep an eye on that. And then for the more detailed help that was mentioned, so just zip over to the risk assessment interface. Here's the right-hand panel that Caroline had mentioned. They've got a lot of good starting information there. There's also links to the in-depth help in here, as well as some short popovers on the user interface as well. So for the in-depth help, you can either go to Help Center for the main page or About This page if you're in risk. And that will open up the full Help Center. And since we did the About page, this is opening on the risk assessment page. If you're coming in from the Help Center homepage, that same material is under the planning cycle, strategic planning, and risk assessment. So there's our overview page again. And there was a question on risk considerations and comparisons. So we've got our really quick step-by-step tutorial, inputs and outputs, and then considerations on choosing HVRAs, some information on potential comparisons. So that's all listed in the Help Center there. So I think those cover the main things that came up during the presentation. You want me to hand it back over to you, Caroline?
I don't think you need to hand it back, Josh. Nicole, was there any other questions, or did you have any final words?
I just want to say thank you, everybody, for attending. I've kept up with the question and answers in the box. A lot of them actually had more to do with the modeling of landscape and probability than risk itself, because you just did such a perfect job, describing everything we do for risk. But I did want to plug again that what Josh shared with the help, we have a lot of technical documentation, so most of your questions can be answered in the help, but always feel free to reach out to us using, the forum, user support ticket, or you can probably find us to reach us directly too if you have specific questions and want to have a conversation about what we've implemented in IFTDSS. Always feel free to reach out. We may ask questions of you too, though, as a warning. So yeah, I just wanted to say thank you so much for attending, and we're very excited because we just released this last week and wanted to get a webinar done quickly to show you guys just the functionality and how it works. And like I mentioned at the beginning, we will do follow-up webinars doing more about how you actually apply this and use this, the risk assessments, once we have the reports out.